I now have the honor today of introducing the keynote speaker for this year's College of Science degree celebration, Paul Misener. Now the founder and principal of Misener Innovation, LLC, a consultancy dedicated to helping organizations innovate, advocate, and communicate. I first met Paul during the time he served as Global Vice President at Amazon.com. With that organization for 23 years, most recently Vice President for Global Innovation Policy and Communication, Paul represented Amazon to external organizations and internal colleagues worldwide. Who better to discuss the value of degrees received, true multidisciplinary partnerships, and lifelong learning? Paul, whose education included his senior research in physics before receiving his undergraduate degrees in electrical engineering and computer science from Princeton University. Also an attorney and alumnus, Paul demonstrates how to engage and build lifelong partnerships with George Mason to make a difference in your communities. He received his Juris Doctor from George Mason in 1993, the university's Distinguished Achievement Award in 2001, and was awarded Honorary Doctor of Humane Letters by George Mason University in 2023. Please join me in offering a warm welcome for Dr. Paul Misener.
Dean Edwards, thank you very much, not only for the introduction, but the invitation to come speak this afternoon. Graduates, scientists, congratulations to you all and to your families and friends gathered here today. You know, about 125 years ago, at the turn of the last century, science and scientists knew nothing of special relativity, of general relativity, of quantum dynamics, of plate tectonics, of DNA, of fission, fusion, and very little or nothing about dark matter and dark energy. We find ourselves in the same spot today, unfortunately. But one of the beauties and privileges of science and being a scientist, as you are, is to make discoveries about the natural world in which we live, like these discoveries that occurred during the 20th and early 21st century that I just listed. You already have some deep scientific knowledge and training, as your degrees attest, but as you deepen your scientific knowledge and expertise, I encourage you to broaden it as well. When I was a brand new lawyer at a big Washington, D.C. law firm, I often was assigned to some of the very most interesting cases and clients. Why? Well, it wasn't because I was the best lawyer in the firm. I clearly was not. As a new lawyer, I was arguably the worst lawyer in the firm. But why did I get these choice plum assignments? Because in addition to being a lawyer, I was an electrical engineer and computer scientist. I had an appreciation of a completely different discipline, orthogonal to my law degree. And so I was not afraid to address technological topics in legal cases. Now, although all of you may never study engineering or law, I do encourage you to think about broadening your horizons with other fields of expertise. And it doesn't mean you have to go and get a college degree again, or another degree of some sort, or a graduate degree in a different field. You can, of course. But there are certifications available. There's even self-study. Just make yourself valuable in a discipline beyond your core scientific discipline. Now, nature and society themselves are both multidisciplinary. And so for you to become multidisciplinary, you will be a better and more valuable scientist, and you will be better prepared for discovery. Another great privilege of being a scientist is to serve as a trusted resource to non-scientists who look to you for information about science that they don't know maybe don't understand, but you are that resource now. You are available to non-scientists. Back in 1999, Jeff Bezos interviewed me for this role at Amazon that I held. And we spent 2.5 hours together in a quiet restaurant just talking about all things. And at one point he looked up at me and said, "How many gas stations are in the United States?" Like I knew. That question was completely unforeseeable. There's no way I could have studied for that. And yet, you have to answer such questions from time to time. In fact, in your careers as scientists, you will find yourself answering unforeseen questions from your colleagues, your fellow scientists. That's the way scientific discourse occurs. Did you think of that? Did you try that? What about that paper? Things that you don't know about yet, but that's part of scientific discourse. But non-scientists, the questions they ask you are far more predictable. They're foreseeable. They're going to ask you about topics that are interesting to them or to society more broadly. They're not going to ask you necessarily about your expertise. That would be an amazing coincidence if they did, but they're going to ask you about topics on their mind. And they're seeking your advice, your guidance, your information as a scientist. Okay, so what are these questions? Well, Natasha and I did not actually coordinate our talks, but it turns out that one of the main questions people ask of a scientist is, how old is Earth? Does everybody know? You should know. You're a scientist now. And it turns out that Earth is about 4.5 billion years old, about a third of the age of the universe itself. And it turns out also that this is 1 million times older than it was thought to be in the 17th century. 17th century, the best academics of the day put the age at about 5,000 or 6,000 years old. Well, it's way off. It's 1 million times more than that. That's not a rounding error. Okay. So next question they may ask, and Natasha would be a great source on this, what's out there in the universe? You know, I look up at the night sky on a clear night and I see a couple thousand stars. Does that mean there are 1,000 stars or 2,000 stars up in the sky? Well, sure, there's at least that number. And in fact, in the local clump of stars in which we live, the Milky Way galaxy, there are 200 billion stars, a little bit more than 2,000, 200 billion stars. And it turns out that there is something like 100 billion galaxies like the Milky Way out there. So do the math. That comes out to something like 2 times 10 to the 22nd stars. That's 20 billion trillion stars. And that's a lot of stars. But it also turns out that that's only about 4% of the universe. The other 96% is not included in those 20 billion trillion stars. But don't take my word for it. I am not an expert. I freely admit I am not. But there are experts out there. So consult credentialed scientists practicing in their field of expertise. The information's out there. You can find it pretty easily. Start with Wikipedia. It's not a bad place to start. Consult the sources and get smart enough on this that you could have that kind of a high-level conversation with a non-scientist who asks you what's out there in the universe. You should have an answer. And one of the cop-out answers many scientists might be more comfortable with is to say, well, that's not my field. That's not my specialty. You'd have to ask a geologist or an astrophysicist. I urge you not to miss the opportunity to educate people on the scale and scope and age of the universe. All right, 3 more questions that I think are eminently foreseeable from non-scientists. One, is the Earth at risk of global warming? Well, over Earth's long history, there's some temperature swings in the climate that are much greater than the current rise in temperature. So the conclusion which is naturally reached is that Earth, the planet, will be fine. In the next 4 or 5 billion years, Earth will continue to revolve around the sun. Earth will be fine. Here's the problem. Life won't be. And this is the area of concern. These wide swings of temperature in the climate of Earth, they occurred largely before people were around. Our species evolved about 300,000 years ago. And most of these rapid temperature changes, drastic temperature changes, happened before them, and virtually all of them happened before human civilization, which arose roughly 10,000, 12,000 years ago. So our human civilization has never experienced these kinds of swings that our planet Earth has experienced. Life and people are threatened by global warming. All right, another question. Did life on Earth evolve? Yes. Period. Yes. It's as well documented and known as any scientific fact out there. And it evolved through a non-random process of natural selection. It's just, that's the way it is. It happened, and it's still happening today. That's the answer you want to give to your non-scientist friend. The last question that is imminently foreseeable is about not so much the nature of science or the science of nature, but a combination of two. What is science? Part of the problem is there's a lot of misinformation about what is science today. Some of it comes from what we might call the anti-science crowd. Some of the misinformation comes from what we call the pro-science crowd. You just have to, I think, you want to be in a position of understanding what science is and what it is not. On the anti-science crowd, I don't know, one of the ones you can pick on is, science is so arrogant. They know it all. They tell you all these things all the time. Science is arrogant. Well, that's not true. Now, we all know arrogant scientists. None in this room, of course. But science itself is very humble. It is willing to admit when it's wrong, even if it's been wrong for a long time. So you can imagine a professor working on a particular theory has been engaged on this theory for 20 years. And then some new data comes in, a new instrument is developed, a new theory is suggested. And it disproves what she was working on for 20 years. You know what she's going to say? Well, that's really cool. I was wrong. I'm going to move on to this new theory. Can you imagine a politician saying that? Admitting that they're wrong? Saying that they're going to change their opinions? Science is a very humble discipline, and I'm sure you will keep it that way. But again, don't take my word for it. This is something that you should do some self-study on and take the time to prepare for these very likely questions that you're going to receive from non-scientists. It will take some preparation in advance, but not a lot. You certainly can do it, and it's worthwhile. All right, the two words you're waiting for. In conclusion, it's reasonable to predict that at least as many important discoveries will be made in the next 125 years as was made in the past 125 years. Now, the obvious implication of this observation is that some of scientific knowledge today is either incomplete or flat wrong. We don't know which it is. That's for you to discover. But almost certainly it is. It would be exceedingly arrogant and short-sighted of us to believe that we have everything right today. We don't, and there's some obvious contradictions in science today, like the contradictions between general relativity and quantum physics. How do you work that out? That's a gigantic challenge for you and your generation. Of course, because some of the science knowledge today is incomplete and or wrong, that doesn't automatically mean that the Earth is 5,000 years old, or that only the 2,000 stars you can see in the sky, that's all there is to the universe, or that somehow both climate and life on Earth are static. That's not true. That's a false dichotomy across the board. Rather, this means that so much scientific knowledge remains to be discovered or corrected. And this is the greatest challenge, opportunity, and privilege for you scientists. I wish you all the best of luck. Thank you.